Gleam is a friendly language for building type-safe systems that scale. This is a project I've been keeping an eye on for a while, largely because, as an Elixir fanboy, it's interesting. Gleam is also built on top of the Erlang Beam runtime, which means it gets a lot of the same benefits and ecosystem that Elixir has, but it's focused much more on type safety and its type system, whereas Elixir's adding a type system and super focused on the math side there. This is an alternative approach to building on top of Beam, and it looks very similar. This code looks hilariously similar to what I was used to writing in Elixir, but it comes with a lot of the type safety and other benefits that we would expect. It does have the same piping functionality and behaviors. It has the threads and all the cool spawn tasking stuff that you can do in the Erlang Beam VM, but it gives us type safety as we do it. Here we see, did you mean name instead of alias? No null values, no exceptions, clear error messages, and a practical type system. Whether you're writing new code or maintaining old code, Gleam is designed to make your job as fun and stress-free as possible. Why are we talking about Gleam today? As I said, I've been around for a bit. I've been keeping an eye on this thing for even longer. Why today? Well, Gleam version 1 is finally here. What is their version 1 release like? Let's take a look. Today, Gleam 1.0.0 has been released. This is the first stable release of the language. More on what that means later, as well as a big milestone for the ecosystem. It's been a long journey, and I'm proud of both the tech and the community that we've built here with Gleam. Thank you so much to everyone who has taken part in any way. You've all contributed to the project getting here in meaningful ways of all sizes. So what is Gleam? Gleam is a programming language that tries to make your job as a writer and maintainer of software systems as predictable, stress-free, and enjoyable as possible. The language is consistent and has a small surface area, making it possible to learn in an afternoon. Coupled with a lack of magic and strong desires to have only one way of doing things, Gleam is typically easy to read and understand. Reading and debugging code is more difficult than writing new code, so we try to optimize for that. I will say, this is very different from the direction we've seen in other languages recently. I feel like all the languages people are hyped about and talking about right now are all focused on performance. And that's great. There are a lot of things that need really good performance, especially in a world where JavaScript's taken over way too much stuff. When you end up running into massive performance issues because the language you chose was JS, the thing you want to fix is performance. So you look for things that fix performance. I would make a counter argument. A lot of the time there are performance problems, it's not because the language itself is slow, it's because the language doesn't have a good way to do concurrency. And this is where Erlang, Elixir, Beam, and all these things have a massive advantage. They are so good at concurrency. Their code is still really fast. I'm not saying that Elixir and Erlang and these things are slow. They're not. They're not as fast as a language that is memory manually optimized like Rust, but they're really performant. More importantly, though, they make concurrency trivial to implement. So if you have multiple cores lying around, the ability to just spawn processes on them and collect them in a map without writing any meaningful code is so comically better that I think for a lot of things, these systems are a better replacement for JavaScript than something like Rust. If your performance issue could be solved theoretically by making JS really good at concurrency, you might not need to go to Rust in the first place. And that's why I'm excited here, because there's so many problems where single-threaded JS, even single-threaded Ruby, is obviously not good enough. But we don't need to go to Rust instead. We don't even need to go to Golang instead. We need to go somewhere that is not going to make our lives harder as devs. Maybe it'll even make them easier, while also giving us incredible concurrent primitives that have logical behaviors and scale infinitely. This is how WhatsApp was able to be built with 5 engineers when they were acquired with hundreds of millions of users. That's only possible because the concurrency model of Erlang is so powerful. But yes, theoretically, on a single-threaded benchmark, this is going to be slower than Rust. Complain in my comments. Anyways, Gleam has robust static analysis and a type system inspired by languages such as Elm, OldCaml, and Rust. So the compiler serves as a programming assistant, giving you additional context to help you make the changes you want to make. Don't worry about writing perfect code the first time. With Gleam, refactoring is low risk and low stress, so you continue to improve your code as you learn more about the problem at hand. It's cool that refactoring is part of their design goals of the language. I think that's somewhat rare. I'll say Rust is good about this. Not good in the sense that you can meaningfully change the way a code base works quickly, but it's good in the sense that if you make a mistake while making changes, you get yelled at a bunch, and it helps you think through those things. Whereas TypeScript kind of lets you YOLO while also being able to rename things without it all breaking. Seems like they're aiming for something between those, which is exciting. Running and administrating software is as important as writing it. Gleam runs on the Erlang VM, a mature and battle-tested platform that powers many of the world's most reliable and scalable systems, such as WhatsApp. I will admit, WhatsApp being our go-to thing to cite, we need more. We really need more. There are a lot more. The telecom world is deep on all things Beam and Erlang. That's what it was built for originally. But we need better companies to cite here. Gleam can also run on JavaScript. Wait, I did not read that part. What? Gleam can run in JavaScript runtimes? Huh? Okay, that changes things. So now you can run Gleam code in browser, on mobile, or anywhere else. Here's an example of some Gleam. Handle request. Request, context, response, use JSON, Wisp, cool. This is using the Wisp to get JSON out of the request. Let result, use data, try to decode it, the JSON as a person, which is a model that has been imported, I'm assuming. Yeah, my app person. So we've created this model. We're trying to decode the JSON as that model. Then we're trying to insert the person into database. And we have the row now. Okay, person.toJSON row. So this is taking that row and asserting that that's okay. Then we have a result case. If okay, then we JSON respond. And if error, then we say it's an unprocessable entity using Wisp, which is, I'm assuming, their web framework. Gotta love some good pattern matching. This is so nice. Just case result. And then the cases are two things that could be the case. So okay JSON is only true if the JSON result is okay. If it isn't, then error empty is the case instead. Nice and clean. Good stuff. What does Gleam v1 include? Well, this version covers all the public APIs found in the main Gleam Git repo, which is the Gleam language, the compiler, the build tools, the package manager, the code formatter, the language server, and the compiler for WASM APIs and JS bindings. That's a lot to include in a v1 release. It's also really nice seeing the code formatter and language server being prioritized enough to be in this announcement post, especially code formatter. Huge shout out to Go for normalizing this. The idea of what if the language just had one way it was supposed to look so that the developers can stop bitching about syntax constantly. We just pick it for them and then it works. I love that. The fact that this is now normal for new languages is so cool. I still remember when Elixir added format. It was so hyped to not have to worry about those things in my code base anymore. Go was first at this. I believe there's some things in Rust now too. But having this be a thing from the official team squashes out so much bullshit. Think about how many videos I've made and how much time I've wasted just complaining about ways to format ternaries. That doesn't happen when you have a formatter built into the language. Really cool stuff. They also have the language server, which is great because this means not only can you have a good experience in whatever editor they chose to support, which is obviously going to be VS Code, now someone like Prime can go build the bindings to use this language server inside of Vim. And it takes almost no time to do that if you implement the language server protocol correctly, which I'm sure they did if they're advertising it here. Really exciting stuff. And also the WASM stuff, which we're going to have to play with at the end of this, so stick around if you want to see me actually trying it. The Gleam standard library and other packages maintained by the core team will be getting an accompanying v1 release shortly afterwards. Before these are released, we will be making pull requests to popular community packages to relax their package manager version constraints to ensure that updating to v1 is as smooth as possible for all Gleam users. That's really cool. Since they're a 1.0 now, it might not be that different from 0.9 or whatever it was on before. And a lot of community stuff probably says it requires v0.9, which means Semver is going to say, hey, you can't install that on 1.0. Rather than just letting that be the community's problem, they're going to go file pull requests to those major packages to bump them to 1.0 and make sure they're ready for it so that the packages the community relies on now won't be as painful to install. Really cool to see. But what does v1 even mean for them? Well, version 1 is a statement about Gleam stability and readiness to be used in production systems. We believe Gleam is suitable for use in products that matter, and Gleam will provide a stable and predictable foundation. Gleam follows semantic versioning, so maintaining backwards compatibility is now a priority. We'll be making every effort to ensure Gleam does not introduce breaking changes. The exception to this is for security and soundness issues. Should a critical bug of that nature be discovered, we reserve the right to fix a security issue, even if some programs were taking advantage of the bug. I've noticed this is a big thing in the Erlang community. They really hate breaking changes. Elixir has been considered a completed language by the core team for a while now, and most of the features are fixes to things and like quick API patches to make other people's packages more capable within the ecosystem. But they're not adding new language features to Elixir really ever anymore. One of the main reasons that they've done that is they built a language that's so extensible that the things you'd want to add can largely be added via libraries, plugins, and other packages. And that just seems like how the Erlang world works. To be fair, they're all running on a VM that's like 30 to 40 years old, so it makes sense they want the old things and the new things to run well. But it is cool to see all these languages building on top of it, maintaining the spirit of never breaking your stuff. So what's next for Gleam? Gleam's a practical language intended for making real things. So our focus with Gleam post v1 is to be split between the productivity for Gleam users and sustainability for the Gleam project. Productivity side, they're specifically calling out the breaking changes again. They'll also be avoiding language bloat. It's a big thing they called out earlier. They clearly are inspired by like Go and how simple things are. They want there to be one way to do things. It's cool that they want to maintain that. It's easy to keep adding new features to a language to aid with specific problems. But with each new language feature or new way of solving a problem, the language as a whole becomes more complex and harder to understand. Simplicity is a feature in Gleam, and that will not change going forward. There is scope adding new features to the language, but we will be doing so extremely conservatively. Any new feature has to be generally useful and enable new things not otherwise possible in Gleam, while being a worthwhile trade-off for the added complexity it brings to the language. I like that they're calling this all out early. Like, here is how we're thinking of what to and not to add to our language. Rather than adding new features to the language, we'll be continuously improving the Gleam developer experience and enhancing real-world productivity. Initially, the focus will be on improving the language server, as it's immature compared to the rest of the Gleam tooling. These really honest callouts are rare and nice. I've never seen a post like this, just straight up saying, this part's not good enough. We're going to fix it. We'll also be working on all of the libraries and such that folks will likely want when making production systems in Gleam, with an additional focus on development of websites and web services. Makes sense that they're targeting this. It's cool that they're aware of this being the right initial focus and eventually doing more like microservices, scalable servers, all those types of crazy things. Documentation's always a priority. We want to have tutorials and guides for all manner of tasks in Gleam. It should always be easy to find how something is done in Gleam so you can focus on achieving your goal. Here's the sustainability section. Gleam's not a project from Microsoft or Google. It's a community project. There's one full-time dev working on it, me. I'll get his name right after, as well as a number of part-time volunteers who do excellent work. With this small team, we need to be efficient with our efforts. Anything we work on needs to be impactful and meaningful to the whole Gleam community. We cannot afford to spend time on niche or unimportant situations. I want to quickly call out a couple things. First off, I want to get the name of that author. I should just go back to the blog post to get that at the bottom. I also want to call out Fly. Fly's dope. I know they're not a thing I talk about a lot. I have a couple videos where I cover stuff they're working on, but Fly has quickly become one of the most important contributors to the Erlang and Elixir ecosystems by a lot. And they're really taking the opportunity here to jump on another thing in the Beam world. Really cool to see them jumping on this and helping support a project like this, especially if this project is by poor Lewis all by himself right now. So huge shout out to Fly for jumping on these things as much as they do. And as they say here, anything they work on needs to be impactful and meaningful to the whole community. Otherwise, they can't afford it because they don't have the time to spend on niche or unimportant situations. Internal docs are also important. So an open source project, we want folks to be able to open up the code base and make their contributions as easily as possible. So far, the feedback has been that Gleam's compiler and build tools are easy to contribute to. That's encouraging, and we'll continue to work on this to ensure the Gleam project never gets to a point where only a select few people are able to meaningfully contribute to its maintenance. Let's take a quick look on GitHub. First off, I need to start this repo because holy shit, this is really cool. 6.2K stars. I'm expecting this to be over 10K by the time this video has been out for 24 hours. So hit the link in the description, go give them a star. We need to support cool new projects like this, especially when they're being done independently. But what I wanted to see here is insights. That's actually huge. Obviously, he's been working on this forever now, but seeing multiple new people coming in with really solid amounts of contributions, especially if I was to shorten the dates here, which I think is a thing you can do via the URL, if I recall. Okay, I can't trivially do that. There's some way to modify the URL so it shortens to just be like a time window. But it looks like recently, there are some people making massive contributions. 139 commits from a third party that's working on this part-time. I mean, he's a core team member, but it's clearly not his job. As well as Anoas contributing a ton, CrowdHailer. Having this many people over 100 commits is nuts. For reference, here is ESBuild, which is the glue holding together a ton of the web ecosystem right now. And here you see the next highest number of commits is 16. And then we have 7, and then we have 6. Here we have significantly more. I'm not picking on ESBuild when I say this. I just think it's important to understand that different projects and different communities have different expectations around contribution. And it seems like Gleam's made it a high priority to make contribution meaningfully easy. And it's showing in the numbers already for something this early. That's huge. I haven't looked at the code base. I can't say for sure, but I'll back up to the feedback here that it's easy to contribute to. Seems like people are making good contributions. Okay, this is an important piece. The last part of sustainability is financial. I'm able to afford to work on Gleam full-time thanks to the support of the project sponsors on GitHub sponsors. The largest contributor is Fly, who provides approximately half the funding. Thank you, Fly. We wouldn't be here today without your support. Going forward, I'd like to diversify the funding with more corporate sponsors, as well as other revenue streams. I earn less than half of what I would make with the median lead developer salary in London, the city in which I live. This is enough money for me to get by, but I would very much like to earn around what I would if I had some other job. This is very fair. If you're inventing a new programming language, hopefully you can get the sponsors and support that you deserve. And again, to anybody watching, if you have the spare funds to support this developer and you're interested in what he's doing, absolutely do that. If you work at a company that might benefit from the work he's doing, bring that up internally. It's always a good thing to have your name in these types of sponsors, and it's surprisingly cheap to do. If we go look at his GitHub sponsors, I bet a lot of the numbers are public. He has a goal of 256 monthly sponsors. Does not have it public. Oh well. Regardless, as he said, he's making around half of what a median lead developer salary would be in London. So let's see what this would be. That's 75k euros. So about 100k USD. That's what I was going to guess. Checks out, which means he's making half, which is 50k. And Fly is contributing half the funding, which is another half. So Fly is contributing 25k a year in order to be this giant logo on the homepage. Do you know how cheap that is? Do you know how cheap it is to put your logo on a homepage for an up-and-coming programming language like that? That's insane. If you're a company that's interested in the Erlang ecosystem, throw this dude some money. It's cheap. You get huge positive press and involvement in an awesome new growing project, and you're financially supporting it. And it's probably going to go way further than 25k would in a traditional marketing budget. Jump in here. It's a huge opportunity, and I'm pumped that Fly's taking it. And honestly, Lewis, I hope that this helps. Like, let me know if in the comments, in my DMs, however you want to reach out to me, if there's anything else I can do to help, because projects like this deserve really good, sustainable, long-term support. We even call this out here. Long-term, you'd like to financially reward the regular contributors to Gleam. Folks in the core team are talented, and they should be rewarded appropriately for their work. I totally agree. And I really hope we can get you some more funding, because you deserve it. They also have a new mascot. Well, a glowed-up mascot. Lucy's a kind and friendly little starfish who enjoys strawberry ice cream and functional programming. Honestly, relatable. The rest of Lucy's story is up to the community to tell. Thank you to Suppy Luppy for the wonderful redesign and for starting Lucy's canon. To go with Lucy's new look, we've also snazzied up the website a little bit and adjusted the colors for legibility. We hope you like it. That's everything. Well, that's really cool things. This is the list of all the people who have contributed, sponsored, and helped. Good stuff. This is so cool. Thank you for reading, and I hope you enjoy Gleam. Enough talk. We need to play with this. Don't tell me they have a whole... How do they have a better learning point than most like modern web tools and frameworks? What? I want to go through some of the tutorial here. Welcome to the Gleam language tour. I'll be sure to leave a link to this in the description if you want to check it out. Hard to put into words how cool it is that they have this already for such an early launch. Like big web frameworks don't even have these tools yet, and this new language by one dude does. Anything you print using io.println or io.debug will be shown at the bottom section along with any compile errors and warnings. To evaluate Gleam code, the tour compiles Gleam to JavaScript and runs it, all entirely within your own browser window. Cool. Here's a program that prints out Hello Joe. That's actually really fast for compiling to a different language and then running. That's dope. Unqualified imports. Normally functions from other modules are used in a qualified fashion, with the module qualifier being before function names. For example, io.println. It's also possible to specify a list of functions to import from a module in an unqualified fashion, such as println. This is the equivalent in JavaScript of import thing from stuff. You could import stuff as like that and then do stuff.thing. But their language lets you do this as part of the import syntax going left to right. I actually really like this. I have a whole video about how we do imports wrong in JavaScript because you can't auto-complete this if you don't know what module it's part of. By putting the module first, by putting the scope next, and then putting the thing you want third, autocomplete can carry you through that. Well, this... Okay, they don't have the autocomplete in the browser, which makes sense, but this has all the pieces they need to do that experience really well. Cool. Gleam has a robust static type system as well. Let's play with the types. Uncomment... Okay, the keyboard syntax and stuff is not quite as good here. It's pretty good overall. The language looks phenomenal though, and the highlighting, everything's solid. Error type mismatch. Source main.gleam io println 4 expects a string and it got an int. If I wrap this in string, now it's good. Or I could change it to debug, which will take things that aren't strings. Nice. Gleam has no null, no implicit conversions, no exceptions, and always performs full type checking. The code compiles, you can be reasonably confident it does not have any inconsistencies that may cause bugs or crashes. That's like a certain other language that is not my favorite thing in the world. It's cool they're doing it here though. Gleam's int type represents whole numbers. Quality, double equals, that isn't stupid, nice. When running in the Erlang VM, ints have no maximum and minimum size. When running in JavaScript, ints are represented using JavaScript's 64-bit floating point numbers. Cool, that they have like this explicitly called out. The Gleam int standard library module contains functions for working with ints. Cool, they have a library just for doing ints and doing them properly. Int.max, int.clamps. My question would be, if I delete this, everything still behaves fine, yes. So these are you only need to import int here in order to use it for the int max, int clamp, and these standard library functions. Seems like the standard library is in a good state though. Certainly not a thing I can say about my favorite language. Gleam's float type represents numbers that are not integers. Cool, we know what a float is. Number formats. Oh yes, thank you for the underscore syntax. This makes my life so much easier with random big numbers. It's really nice. You even do floats. Oh, that's really nice. Gleam has equals and not equals operators. Cool. Strings. That is a classic concatenate option. Always cool to see things like this being built in and working. All the Unicode escapes all built in. Looks good to me. Bools either true or false. We know how Booleans work. Assignments. I have to test something important. Let fire equal testing. No, I just wanted one more language that would let me use emojis for variable definitions. Why can't any language let me use variables that are emojis? I'm not asking for a lot. Yeah, only Swift allows this right now. It's the one thing that I want more languages to do. Just give me emoji support for my variables. And Julia does, apparently, according to chat. Good to know. Assignments, variables can be reused later, but the value they reference is immutable. Nice. Immutable values. We love that. Discard patterns. If a variable is assigned but not used, Gleam will emit a warning. Variables intended not to be used, the name can be prefixed with an underscore. So I just don't use that, we get a warning. With the prefix, we don't get a warning. That all being part of the language and compiler is really nice. Type annotations. Let assignments can be written with a type annotation after the name. Type annotations may be useful for documentation purposes, but they do not change how Gleam type checks the code beyond ensuring the annotation is correct. Interesting that this is optional. They really leaned into the inferred everything, which I love. It's so cool seeing type inference as like the core of the language. Try changing this. Int, cool. If I change this to not be underscore name, and I try to change this to name equals 4, nope. I'm curious if we can do crazy things with the type definitions. Hub type user ID is int, user ID int, cool. Also able to resolve deep there. Nice. Blocks. Oh yes. Thank you. I've had like 3 problems in code reviews in the last 2 days that made me want this in JavaScript so badly. Do you know how great this is to not have to like make a function just to call it to keep variables within a scope? What this does, for those who aren't familiar, is it lets us define a bunch of shit in here. So if I just was to also do like let Celsius equals some random shit, io.debug Celsius, just so that they're all being used. Celsius isn't touched here. Even though I defined it there, since it lives within this closure, it effectively disappears afterwards, which means whatever you do at the end here can now be assigned here. I can have this little section that goes and does its own shit and not have to call a function or inline a bunch of stuff. It just does it. Oh, no, can I do return? They have a return keyword. They don't. That's annoying. I hate implicit returns. I like explicit. Can functions return things? Or is it literally just whatever you put at the bottom? This is whatever you put at the bottom. Not my favorite thing. Fine. Yeah, having block closures like this is so useful. I am hyped on this. Yeah, and again, the example here is if you uncomment degrees, this won't compile because degrees is only defined within this scope. It's not defined outside of it. So this won't work because we don't have access to it because it was put in these brackets. That is so nice. The number of random functions I've defined that just call themselves, so this helps us escape, magical. Lists. Lists are ordered. Cool. Yeah, we know how lists work. The interesting thing here is that lists are immutable. Very similar to Elixir. I think it's a thing in Erlang as well. Immutability is great. Love this. Lists are immutably single linked lists. The benefit here is you don't have to worry about like running a dot reverse and it breaking your original list. If you want to make changes to your lists, you make a new list. This is how it should be. I love this. Naman's the creator of StyleX. He loves lurking in chat. And I trust his takes on language design. If the only issue he has with Gleam is implicit returns, that sounds like a pretty good language to me. And I'm thus far leaning the same way because, God, this is really impressive. The more I look in, the more happy I get. Constants, cool. We know how constants work, but they're actually constants, unlike in certain other languages. Who would ever make those other languages? The fn keyword is used to define new functions. The double and multiply functions are used or defined without the pub keyword. This makes them private functions. Interesting. Oh, just pub. Yeah, no, that is expected. Pub is just to make this exported so other things can access it. I thought that was more complex than it is. That's really simple and obvious. That's the equivalent of like export. Nice and simple. Higher order functions. Nice. Functional programming languages need the ability to stack functions. And it looks like we can do that. We have add one, which takes an int, and it returns argument +1. That syntax looks really familiar for type definitions. Rust devs must be pumped right now. Twice. Argument. It also takes in a function into int, and it runs this function twice. That's cool. I wouldn't name this function. I'd say past func. I'm sure I can. No. In Gleam, functions are values. They can be assigned to variables, pass other function, anything else. Here, function add one is being passed as an argument. FN's not what I should use there. Past func. Somebody said, is it camel case? Yeah, it's you can't camel case. Past func, not a valid name. They actually enforce camel case. Cool. I just didn't like this being called function because confusing. Cool stuff. Anonymous functions. Again, really important to be able to quickly inline a function when you need to. Shouldn't always have to define shit. So in this case, we define add1 equals fna a +1, and we pass that as a variable here. Nice, simple, to the point. Cool stuff. Function captures. Gleam is a shorthand syntax for creating anonymous functions that take an argument and immediately call another function with that argument. I'm trying to figure out how to explain this. This is an interesting bit. Anonymous function can be written as with any number of arguments passed to the inner function. The underscore is a placeholder for the argument. Okay, so add one v2. Oh, okay, now I think I know how to explain this. So if you want to quickly define a function that is just calling another function, if you put underscores for the arguments, those become the arguments for your function. So if I change this to be random string, this variable is never used, but if I io.println random, now we're getting an issue that we didn't pass the argument here. So I'll pass hello here. Now we're getting the same thing here. The interesting thing with the underscores is now for add one v2, I've basically told the compiler add one v2 takes 2 arguments. And they're these 2 in this order. So since I put these blanks here, it will just expose those in the add one function. So now I can do, hi, there's more than one argument hole in this function call. I assumed you could do multiple. Oh, it's just for one argument. Okay, it makes sense that it's just for one argument. Limits what you can do with this, but it is convenient to do something like that, where a function needs some things passed, but you want to expose just one thing to be quickly called inline. It's a quick way to do that. Be cool if you could do more with it, but it's a nice quick syntax. There's also generic functions, the thing that Go finally added, generics in general. Anyways, up until now, each function has accepted precisely one type for each of its arguments. The twice function, for example, only works with functions that would take and return ints. Cool. So twice takes in a function with value, value, value. This is generic though. So theoretically, you can define whatever you want this to take. We have an add one here where function of x is returning x plus 1 and exclaim, which is function of x, exclamation point. So these both are, this would infer to a number and this would infer to a string for the inputs. Here, the type variable is replaced by the type int. So as we're calling twice with the number 10 and add one, it knows that's a number. The type definition gets handled. Let's change this to exclaim. We'll get an error because exclaim's been inferred to need a string instead of a number. And since we gave it a number and a string, twice is smart enough to infer that these things are different, that the value in the type definition here is different from the type definition for the function return. And since these are different, it gets mad at you. This is really cool reverse inference. It's nice to see this in a language that isn't Rust or OCaml. And my favorite, my absolute favorite, the thing I cannot believe has not made its way to JS yet, pipes. It's so good. It's so simple. There are so many times where you, let's be real. Who has written this code before? Let's say we have const user equals some stuff. Now we need to do something with the user. Const auth user equals auth user. Then you have your function that actually does something to it, like you format it or you process the payment. So const processed user equals process auth user. And then return process request processed user. There's only 3 possibilities for everyone here. Either you don't write JS, you write JS and you've done this a bunch, or you're lying. Because this is one of the most common things I find myself doing where I'm defining 15 variables just to use them once as I pass them to the next thing. The other option I could have here is I could take this, put it here, take this, put it here, take this, put it here. And no one likes this, especially once the chains get big. This is the worst. What if, instead of compromising on both the line syntax as well as from having to define a bunch of variables, you shouldn't have to name every single step along the way. What if a pipe just took the thing from the last line and made it the first argument in the next line? So here we take 1, we append 2 to the end, and then after, here's where it gets interesting. Because we have the blank here, we're passing 1 to that spot instead. If we don't have that, it just goes in the front. We get 1, 2, 3. But if we put that blank, we also put it here, and that's going to be 2, 1, 3, because 1 gets put after 2 when you put the blank there. 3 blank, same deal, 3, 1, 2. Tell me that's not the coolest shit in the world. Tell me that's not hilariously cool. I'm going to try one thing. I'm actually not sure if this will work, but I'm so curious. Hello? Oh. Since this isn't a whole argument, it's not smart enough to pass it through. It was worth a shot. Still so cool. I love this so much. Labeled arguments. More really handy, useful features. When functions take several arguments, it can be difficult to remember what the arguments are and what order they're expected in. To help with this, Gleam supports labeled arguments, where function arguments are given an external label in addition to their internal name. So this is what it's called externally, multiply. Internally, it's going to be called multiplier. Externally, it's going to be called add. Internally, it's going to be addend. Cool. Not super important, but nice. Documentation comments. Documentation comments are important. They have regular, double slash, as well as triple and quadruple slash, which are used for attaching documentation to code. Triple slash is for documentation for types and functions. Quadruple slash is for modules and should be placed at the top of the module. So here's the definition for the module. Here's everything else. I would like something different than additional slashes. It's a little too easy to glance over and not notice the difference there. But the fact they have syntax for this built into the language, version 1, is really nice. Deprecations, cool. Everything should have that. Case exceptions. They have a whole pattern matching section in here, maybe. A bunch of flow control stuff. I could sit here all day just going through the different language decisions. I don't want that to be what this video becomes, but I do want to take a look at cases and pattern matching. So here's a pretty simple case. We have x, which is a random int, 0, 1, or other. We pass it, it's x. Well, that results. If it's 0, we print 0. If it's 1, we print 1. Otherwise, we print other. If I refresh this, you get different values each time. Cool. I'll ask the programmer to say, if this data has this shape, then run this code, a process called pattern matching. I'm going to do something silly. I'm just curious if this works. 1, 2, 3. Here, we can pattern match to say 1, 2, we don't care. 1, 2, 4. And then here, we don't care either. Int is never used. Cool. First case, second case. And this will be a good example. So we'll do 1, 2, 3, and then 1, 2, 4. And then 1, 2, underscore. So we're going to get the first case here because the array is 1, 2, 3, and it matches 1, 2, 3. Where things get magical, though, is you can opt out of certain arguments. There's now unreachable cases, which makes sense. That it's actually really cool the compiler is smart enough to notice that. So I'll actually delete these other cases because the point of this one is very simple. If 2 is in the middle, doesn't matter what the other values are, this is what we should run. This is so nice. The alternative here would be in like a case true, and each of these values would be doing a manually written if check in something like TypeScript. But here, it's just built into the language in the case syntax. When you pass something like an object or an array, the level of specificity in your match is up to you. That is so good. You could also, somebody just said, define a variable here. So if I wanted to do first case foo, can I cast this as a string? Let me import Gleam int.toString, I'm assuming. Oh, look at that. Look at how helpful their little compiler stuff is. So now, since we bound foo as the third argument here, we can actually pass it. But we could also make a case here that's like 1, 3, 4. We don't have that variable, so I'll just delete that for now. And the magic here is whichever case your code passes first is the one that you hit. If I change this to 1, 3, 3, it will only match the bottom, so we get other. Change this to 1, 3, 4, it matches this middle case. If I change this to 2 in the middle again, even if I have 2 here, it'll hit this first case because it matches and it's going through step by step. So it says, okay, here's the first one. We don't care about the first argument. 2, 2, cool, that matches. 4, foo, cool, we can bind that. Everything matches, cool, run the code. Wait, no, it doesn't. Check the next one. This is, I don't know how to put into words how much this helps with maintainability. It looks good here. Once you get into function overloads, where you're defining the same function 4 times and defining these things in the syntax for the function definition, that's where it gets crazy. I was curious if they have function overloading. That's the one thing I would really like. Oh, that's the one thing I really want. They actually have, oh wow, they have a whole guide for Gleam for Elixir users. They're really focused on this stuff. That's dope. Unlike Elixir, Gleam does not support function overloading. There can only be one function with a given name, and the function can only have a single implementation for the types it accepts. I get it. I'm sad, but I get it. There had to be some negative, right? Couldn't be literally perfect language. It's close. It's weirdly close, but it couldn't be perfect. I think I've covered everything I want to here. It's clear there's way more. I didn't even start going into Lustre, which is their web framework. It's not actually by the core Gleam team, but it is a supported functioning web system for writing Gleam in the browser, which is really, really cool. They're already at that point. I haven't been this excited about a new language in a minute. I'll be honest. I am blown away. If you haven't already checked out Gleam, go take a look. And if you can, support the team making it because they're clearly working really, really hard. That's all I have to say for now. Until next time, peace, nerds.